Thanks for joining us on the Future Food Show. On this episode, we're delighted to have Dr. Ali Khademhosseini on the show. Ali Khademhosseini is one of the foremost tissue engineers in the world. He is a founding director at the Terasaki Institute for Biomedical Innovation, out of which Omeat was born. After learning about the environmental impacts of the conventional meat industry, Ali realized his extensive background in tissue engineering could be applied to develop a process for more sustainably produced cultivated meat. Khademhosseini pivoted his focus to enter the field, developing Omeat's unique cultivation process poised to redefine the industry. The company has developed a highly differentiated, IP-backed approach that enables the cultivation of any kind of meat in a way that's orders of magnitude more sustainable and humane than the conventional approaches. We had a great discussion with Ali, learning about his background, experiences, and the passion behind the project. Ali, I would like to welcome you to the Cultured Meat and Future Food Show.
Thank you, Alex. I'm super excited to be here.
Ali, tell us a little bit about your background.
Sure. So, kind of like you, I'm originally from Iran. I grew up most of my life in Canada. We left Iran when I was young. And I got more and more fascinated by science and technology as I was going through my education. I did my undergraduate at University of Toronto in chemical engineering. And then I went to MIT. I was lucky enough to get accepted into really one of the top historical figures, I would say, in science, Bob Langer, who's a co-founder of Moderna and 50 other biotech companies. So that was really a life-changing experience, being at MIT, being around so many incredible people. And I got involved in tissue engineering very early. I just thought it was the most important, interesting thing that one could do, make transplantable organs and use everything I learned throughout my education in engineering to be able to do that. So I thought that was amazing. And I decided to pursue that after my PhD. I was lucky enough to get a faculty position at the Harvard MIT Health Sciences and Technology Division, as well as Harvard Medical School. So I spent about 17 years total, 12 years as a faculty in Boston. And then I came over to Los Angeles 6 years ago. I really wanted to live in California my whole life. So this opportunity came along and we jumped at it. We moved with my wife and I, and we soon afterwards had our first kid. And everything in LA was going incredible. And I got this opportunity to start this new research organization. So I left UCLA to do that at the Terasaki Institute. And while I was doing that, I spent a year at Amazon learning about their scale up and culture approach to scaling up and maintaining a culture in the company. And it wasn't until probably early on when I was at Los Angeles that I got really excited about cultivated meat because I finally understood the environmental impacts of it. Being a tissue engineer, I knew about cultivated meat for many years. Since the beginning, I've known Mark Post since he published some of his first work in this area and also had the burger tastings. So I've known about the area, but it wasn't until very recently that I became passionate about it.
Cool. And I'm excited to dig more into that. Can you give us maybe a quick overview of what the Terasaki Institute is?
Yeah. So the Terasaki Institute is really what I always thought a research organization should be like. And being at universities, both public and private universities, you see what works well in academia and really what are the issues that academia has. So when I talked to the Terasaki family who had this foundation with an endowment and buildings, I basically pitched to them that let's try to do something different. Let's try to create an institute that does research focusing on the most important problems in human and planetary health. And why don't we try to do this institute in a way that it actually functions differently from a, let's say, institute at the university? Why don't we focus this on entrepreneurship and innovation? Why don't we give the faculty and the scientists at the institute more flexibility and freedom to not only work on the problems that are of most importance, but also be able to spin out with these companies while maintaining a presence at the institute, potentially continuing some of their nonprofit research, but at the same time have a foot in the companies that their research is spawning. And this is something that at a typical university is particularly hard to do because universities have competing missions like education and many other things which are ahead of an innovation mission. So, what typically at a university one can do is do the research in the laboratory at the university. And then when you start the company, you have to basically make a tough choice whether you're going to be a professor or whether you're going to leave your professor job to be part of the company. And our researchers at Terasaki do not have to make that choice because we manage the conflict of interest that inherently exists by having for profit operations, working with nonprofit institutions. But at the same time, we allow the most passionate people about the technology, which are the scientists who develop it, to be very much involved in the companies and to be able to push it forward. So that's a really a new exercise, a new approach to doing scientific research and innovation, which we wanted to try at the Terasaki. And it's been really fun over the past 3 years to start the Institute and see companies like Omeat come out of it.
You mentioned Amazon. Was that something that you did before, or was it like a sabbatical?
Yeah, so when I was thinking of starting the Institute and became basically committed to doing it, we started renovating some of our buildings because they were not up to the standards that we wanted for the Institute. So that was going to take a year. And I could have just kind of continued at UCLA for about a year and just continued research. But I thought this is a really good opportunity for me to do something different, something that I haven't done before. And particularly for me, being an academic all my life, I always wanted to be having an industry experience. And where better to have an industry experience than a company that is at the interface between technology, has really been able to figure out how to scale to incredible amounts and be able to do something that is totally different outside of the realm of what typical professors do. So I talked to some of my colleagues and actually friends that I've known for many years who are high up at Amazon. And I said, guys, I'm interested in doing something there. And they actually have a unit in Amazon that really focuses on what Amazon doesn't do. And they focus on what the future business that Amazon should get involved in. And they have all kinds of interesting people in that unit, people who have medical backgrounds, people who have sustainability backgrounds, lots of different things. So that's where I spent that year, just diving into interesting problems that exist and how a company like Amazon could potentially make an impact in there. And it was really interesting because that was the first place that I actually saw how real corporation works, how Amazon has been able to successfully make their culture scale to the level where they have 1 million employees, but all those 1 million employees are expected to abide by certain ways of behaving, which is embodied in these Amazon leadership principles. So I just thought it was a really amazing experience, and it has really helped me since then, both with the institute as we start growing, as well as with Omeat as well.
Very inspiring story, and also a very badass way to say, this is how I'm going to spend a year. So, and I think from an entrepreneurial mindset, it's very inspiring. Okay, so that was Amazon. Terasaki got started. And when did the idea for Omeat come about? Because I know that you were familiar with, of course, the technology being used for cell cultured meat. And back in 2013, when the kind of debut from the burger from Dr. Post was there, when did you say, hey, you know what? It's time for us to kind of go in a direction and start Omeat?
So, being a tissue engineer, I've basically been looking at applications of how tissues can be used. Early on, just medical transplantation. Then came the whole idea of using these tissues to model diseases and be able to develop drugs. And looking at this whole spectrum, we always thought that, okay, making meat is fine, but is it really solving a problem? So to me, that was really the reason I was not as keen about this for a long time, because even as a faculty at Harvard and a student at MIT for 15, 17 years, I still did not know a lot about the effects of animal agriculture on the planet. And it was only through that education that I started getting passionate about sustainability and the effect of minimizing animal factory farming on the planet. So that was when I got more and more excited about it. I tell everyone that effects of animal agriculture on the planet is the best kept secret in the world, because just as a general population, very few people care about it to the level where I think we should. Now, as I started learning about it, initially just through very standard medium, documentaries like Cowspiracy and Seaspiracy, and then getting more and more into the science of it, and looking at, for example, the kind of articles that Mark Post was publishing and other people in the field, as well as looking at reports that the Good Food Institute, for example, was producing. So I was really inspired by Liz Speck's report on lowering the cost of medium. And when I looked into it, I said, wow, this does make sense. It is possible to bring down the cost of these sorts of technologies. But when I looked deeper, I felt that, okay, maybe it still requires some new innovations to really enable this transition to low cost medium and being able to scale up the industry. So we started to look at different kinds of solutions. And the good thing is I had my medical background, which allowed us to think differently. So one of the things that we do in a lot of medical practice is to take things like platelets and platelet rich plasma and other sorts of regenerative cues that exist in adult organisms, and we try to use that to induce healing inside the body. That's why people take PRP and inject it into different areas inside the body to induce regeneration. So that's where the whole concept started to emerge. We started looking at the assumptions of the field, and we saw that everyone has been inspired by the same sources, whether it's Mark Post or Liz Speck. And everyone, based on those inspiration, is thinking about doing things the same way. Can we eliminate animals from the food industry altogether? But we started really thinking about problems, and the problems of greenhouse gases, deforestation, all the health issues associated with things like COVID-19, that also is a zoonotic disease, as well as animal welfare aspects, having feedlots and having animals in confined places. So we started to get inspired by solving those problems, as opposed to just saying, okay, the solution to this is to eliminate animals. And that's where the concept of using regenerative factors in adult organisms, particularly cows, and using that to grow the cells and be able to replace not only fetal bovine serum, but also recombinant proteins, and the need for them, at least for any time in the near future, for growing meat at price parity came about. So it's a totally different set of assumptions that went into it, a different way of looking at the problem, and that was the genesis of Omeat.
In over 100 plus episodes of cultured meat, on this show, we have not heard of an approach like this. And I think in many ways, it's like, as you mentioned, it takes kind of like a different eye to kind of see what you're looking at. But let's break it down. Maybe can you explain in very basic terms how kind of this process works? And I think I read somewhere it was kind of making the example of, like, when humans give plasma, that's kind of the same thing that goes into kind of grabbing these, I guess, the growth factors you need from the cow. So can you give us maybe an explain it like I'm five answer to
Sure.
the overall process?
Sure. So we basically start off with cows. Now, these cows are very specific set of cows. We do a lot of testing to make sure these cows don't have diseases that affects pretty much majority of the cows in the United States, like bovine leukemia, for example, which, as in the cattle industry, we don't really worry about it because we kill the animals so quickly. So those sort of diseases never becomes an issue. So we start off with animals that are healthier, and we take care of these animals better. So the animals are in regenerative agricultural models. So the animals are actually on pastures. They are living their entire lives doing things that they had evolved to do, go graze. And by grazing, they can fertilize the land. And there's concepts associated with farming now that is going back to these kinds of principles, eliminating fertilizers, eliminating tilling, focusing on basically cover crops and making sure that the land and the soil health are really taken care of. So this is the latest in farming. And we have our cows as part of this sustainable agricultural models. Now, when a cow becomes part of our program, we don't just say, okay, let's start collection. The cow has actually gone through a training process where we take the cows and we have them go through a positive reinforcement process where they get used to coming in, they get used to getting pampered during the process for 2-3 hours, and then they're let go. And for the first little while, we don't even collect plasma from them. We just make sure that they have positive experiences. Then what happens is that the process is based on collecting plasma from the cows, and these plasma is rich in regenerative factors like platelets, which allows us to actually make medium from the cows that is as potent, if not more potent, than fetal bovine serum. So that's kind of how we start getting the supply chain. So the cows come in, we do a similar process to what a human does. We connect the cow to a machine that separates the plasma and the platelets from the blood. So the blood is not actually depleted from the animal, and we collect the plasma. So in humans, we are allowed to go and donate plasma every time 1.5% of our body mass. So that's what humans are allowed to do. We actually go much lower than that in our cows. We only do one-time collection, and we often do less than 1% of the mass of the animal in terms of what we collect in plasma. So it winds up being a very benign process. The cows in multiple years and hundreds of cows that we work with have never had issues associated with the collection in terms of depleting them of their platelets or plasma in a way that has been medically noticeable at all. So the cows are physiologically fine. And because of the positive reinforcement trainings that we've implemented, they are also psychologically fine. These processes were kind of developed with animal welfare experts, academics, for example, Dr. Horvath from UC Davis, who actually came to our farm and trained our veterinary technicians about how to implement these processes. So that's how the input into the entire process of Omeat goes. So this allows us to make our FBS replacement, as well as it allows us to really come up with ways of reducing the costs. And some of the really incredible things now start happening. And when you think about this, a cow in California costs somewhere between $500 to $750 to maintain. From that cow annually, we can get somewhere around 500 liters of this solution that can replace fetal bovine serum. So just kind of looking at that, that brings the cost per liter of these ingredients down from $1,000 per liter to a single digit dollar per liter. So that's a big 3 orders of magnitude drop in price that is enabled because we're actually working with the animals and not trying to eliminate them fully from the process. So that's a little bit about the process. And obviously what we get from those cows, then we process and we put in our bioreactors. Our bioreactors have their own unique ways that they operate that further enhances our yields. And the whole thing allows us to what we think is the most ambitious cost structures in cultivated meat, which is we believe that right now, just by scaling and not having any new innovations, we can be at price parity in reactors that have already been vetted with sizes that already exist for mammalian cell culture, and also be able to scale more rapidly than any other entity, because we are tapping into what has been built in farm industry for the past 12,000 years. And by not fully basically eliminating that supply chain, we can actually tap into it and scale and actually make the kind of changes that we need to reduce greenhouse gases and reduce animal suffering and make economic incentive to actually eliminate animal slaughter. So that's a whole bunch. So I don't know if it was for a 5-year old, but I'm approaching 50, then I think, it was probably more like for a 50-year-old.
Yeah. Well, I don't know if any actual 5-year-olds listen to the show. If they do, then they're definitely onto something. But okay, so and that's amazing. So and I think if you think about it, when you're making cell cultured meat, if you think about it from a standpoint of getting media that comes from a cow versus something that is like a serum free media, I mean it makes sense that it will operate better and more efficiently in the former. And so I guess one question I had is, you mentioned that the process is done to the cows, and you said less than 1%, but I think you said one time. Is that one time per session or one time for the life of the cow? Can you
Oh,
elaborate on
great
that?
question. Yeah, one time weekly. So
Okay, okay.
that's why humans are allowed to give 2 collections a week. We just do 1 collection per week from our animals, and the rest of the time they're basically just roaming the plains and having a good time.
So a lot of the folks that are interested in cell cultured meat technology, they're trying to get rid of factory farming. In this scenario, the cows actually have a very nice life, and they can roam about and kind of do what they want throughout their day, and they're not going to slaughter, or at least not right away. They're just giving samples once a week. So this is definitely, you wouldn't consider this factory farming.
So there's a few things that I think about in this approach. One of them is, the reason we have factory farming is because we are so many of us in the planet. So 96% of mammalian biomass are humans and our livestock. So that is a big problem. That's why we have to confine animals in feedlots and feed them food that they're not evolved to eat, and a lot of the bad things that comes with factory farming. So fundamentally, animals are a very important part of ecosystem building, and being able to have animals to replenish the soil and to basically add the things that they've evolved to do and live their lives, I think it's something that has happened for hundreds of millions of years. So that's not the issue. I think the issue is the factory farming. And the other thing, so what Omeat does is, we're kind of saying we don't want factory farming and we don't want any animal slaughter. So how do we do that? One is, to eliminate factory farming, we need to make meat production a lot more efficient so that we can feed the people on the planet, but at the same time, we can have a lot less animals. So using very crude processes, things that we can optimize a lot more, what we can do right now is, from a single cow, we can get 20 cows worth of meat every year. Typically, for a single cow that you raise in the United States, you raise it for 3 years, you slaughter it, and you get somewhere about 300 kilograms of edible meat per that cow. Now, in our process, you can raise the cow, you can collect the ingredients in terms of the plasma that we mentioned, and every year you can get 20 times worth of meat per that cow. So, what it does is that it actually eliminates the need for animals by 95%. So, that's one way we think we're actually solving that problem of factory farming. We're decreasing the number of animals needed to feed the population. The other thing that we're doing is, we are trying to actually create processes that encourage farmers to pick up sustainable practices. And there's still a lot of discussion to be had about whether, how much carbon is getting captured by these sorts of practices. But the general consensus is that those types of farms are better for biodiversity, better for the cow and animal welfare, and many other sorts of things compared to what feedlots do. So we are eliminating feedlots. We are enabling sustainable regenerative farming practices. And at the same time, we are trying to create a process that can feed the planet. So that's really what I think Omeat is aiming to do. And because we think of the problems as opposed to just the solution, then I think that's what allows us to think differently about how to fix it.
What I like about the approach is that it's not only kind of improving beef production, but it can also, as you mentioned, help with other types of farming and also crop production as well.
Exactly. Yeah. So obviously, even if he eliminates all animals from the food system, we still need to feed these bioreactors ingredients like sugar and amino acids would need to come from farms. So our vision is that to really eliminate the bad things about factory farming, we need to eliminate even things like fertilizers and monocrop cultures and all sorts of other things that are ubiquitous aspects of farming right now. So it is an approach to try to make a more holistic ecosystem that is sustainable as opposed to just solve one problem associated with a particular industry.
So the company has been in stealth for quite some time. I think I was reading somewhere like maybe 4 years. Tell us about your most recently announced fundraise.
Yes. So the technology has been developing, as you mentioned, for about 5 years. We have been really strategic about not coming out of stealth mode until we felt comfortable that when we come out, we're going to have something to say that was unique, different, and valuable to people. So we raised our Series A last year in June, and we raised about 40 million with really incredible set of investors, S2G, which is a very recognizable name in this particular field, Google Ventures, Cavallo Ventures, Bold Capital, Voyager, Trailhead, many other VCs that I think are really strong, Rethink Food, strong folks. So we were very excited about it. And I think that we felt that the time to actually come out of stealth mode and announce this previous round was when we felt comfortable that we can deliver a message that would not create the wrong impression. Because obviously, as we are doing things in a totally different way, we wanted to make sure that we were doing everything properly. We had thought about many things in terms of not only animal welfare, but how to work between the cultivated meat industry and existing food manufacturers, and how to try to bridge these communities and really do a good job at it. So that was really the reason we wanted to stay stealth for as long as we did.
From a business model standpoint, are you building the technology platform and licensing it, or are we going to see Omeat packaged food, or Omeat packaged beef in the grocery store, or maybe Omeat branded burgers at a restaurant?
So at this point, we're a vertically integrated meat company with opportunities for B2B in terms of our medium ingredients and other aspects that we have. When I started a company, I actually wanted it to be a media supplier. I set up meetings with virtually every single CEO of a cultivated meat community and started talking about, okay, we have what we think is a potential solution to costs associated with the media. Is this something of interest? And pretty much I got two sorts of answers. One of them was companies that are more established and they already have their own media formulations. They've spent a lot of time on regulatory and other sorts of things that they need to do. And they weren't really ready to just change processes based on a new startup coming and trying to sell medium. And then the other part of the equation was these new companies that were perhaps even more of a startup than I was just doing calls to people. So those were the two different spectrums. And given that this is a really nascent industry, there is not a well developed ecosystem to tap into in terms of we've created a supply chain, now we're going to sell it. So we wound up by necessity becoming a vertically integrated company because we wanted to control our own destiny. Now, going forward, there's obviously a lot of opportunities for us to partner with other companies. I always think of ourselves in some ways as perhaps where Tesla was when they were starting to build their electrical cars. They had figured out a solution in terms of, let's say, batteries or things associated with that, but they really needed the ecosystem. They needed the cars, they needed the charging stations. They needed all of that ecosystem to be present for them to be able to really provide a compelling story to their consumers, to their customers. So what we have to do at Omeat is very similar. So we focused on solving the supply chain issue, but because the field was not developed, we had to actually go and build the products. We will likely be in the market within the year and have to get people to like the product. And in some ways it's similar, but we're definitely interested in becoming a supply chain for the industry, particularly in sectors which we deem as totally non-competitive. And this is the beauty of this cellular agriculture community, because we're making leather, we're making milk, we're making seafood, lots of other things, which I think there's plenty of room for Omeat to really collaborate with other companies and create a world that's less destructive than what it is we have now.
As we begin to wrap up, you are one of the world leaders in tissue culture. I wanted to ask you, is there anything that you feel is overlooked when people are talking about the cellular agriculture industry?
Well, I think within the community, there is a lot of great people, but a lot of this has been funded by VCs and kept in startups and non-academic community. There is, I think, for us in terms of what's been overlooked in the cellular agriculture community, I think is really the need for academics. I think there needs to be a vibrant academic community to really be able to dig deep into different aspects of cellular agriculture, whether it's cell lines or processes or microcarriers and media formulations. And that typically in medical world, where I spend most of my time, is done at universities by researchers who are passionate about understanding the science and pushing things forward. In this field, the government has not really stepped up yet to really make a big dent in terms of academic research. And I think that's something that needs to be done. In terms of specific scientific things, I think there is many different challenges that we need to address. There's a lot of work in terms of getting the best cells, getting the cells to differentiate, express the right proteins. There's a lot of things about media formulations and our understanding of what really matters, how to drive the cost down, how to make different components like the fat and connective tissue. So there's a lot of things going on, and that's the complexity of building tissues, which I've experienced for the past 25 years. And that is something that I think really needs to be taken seriously. Right now, I think the beauty of this field is that you don't need to make a functional tissue to sell a product, which is a very different goal than a tissue engineering world where I come from, where you make a heart, it has to function at time zero. Here, if we make something that has some resemblance of meat, it tastes like it, and we can perhaps even add some downstream stuff to make it have the right texture, etc. It all can be, pretty convincing to a person. But in medicine, it's actually much more difficult because you have to have it function. So I do think that to some degree, it's a lower bar in terms of what we need to achieve in terms of cellular architecture and functionality. But at the same time, the fact that it's not in an academic world right now, it's really based on what we do in industry, and just a couple places like Tufts University and UC Davis, perhaps some at UCLA, are the places where a lot of this stuff is happening. I think it needs to go to a different magnitude for us to really make a big dent in this cellular agriculture and solve the scientific problems associated with it.
Yeah, and definitely that's a key point. And I do see that we are starting to see more cellular agriculture programs come up at other universities. So maybe this is just the starting point.
I definitely hope so. It's always refreshing to see that the government is putting in specific amounts of money into this. But just to let you know, like in the medical world, we are putting in literally $40 billion a year into medical research through a place like NIH. We're putting in another perhaps 10 to 20 billion in terms of other government agencies, another 10, 20 billion in terms of pharma companies. So this is just like it's a different ballpark. When people are thinking about cellular agriculture and $1 billion has been spent in it, it's really nothing. When it comes to making an impact at the scales that we're thinking of doing, it's not much. And I think the fact that all of this money, or majority of it, has been equity dollars, is clearly not good. I think government really needs to step up, and not just step up, but step up many orders of magnitude to be able to address the very real problems that we have right now in terms of climate change and other sorts of things, and understand that alternative proteins are going to be a major part of it. And not everyone is going to convert to plant-based options because of a variety of reasons. So having meat that is actually like meat, but doesn't have the carbon footprint, doesn't have the slaughter, doesn't have the additional baggage with it, I think is going to be very important.
You can learn more about Omeat at www.omeat.com. That's OMEAT.com. Ali, usually at this part of the episode, I ask you if you have any last insights for our audience. But maybe even a better question is, what is your favorite Persian food in LA?
Oh, that's a great question. Typically when you ask this to Persians, they say, this kebab or that kebab. I'm more of a traditional guy, so I like some of the fesenjuns and qorme sabzi type of food, which has got meat in it still, but also has got a lot more taste. And that's the other thing I wanted to mention. I am not coming through this through the normal vegan routes. I'm a meat eater, but what I became super passionate about, and I think that's really the one of the messages I want to give, is that this has to become a lot bigger. It has to really consume the masses. We have to get adoption that is incredibly high to be able to make a dent into the kind of destruction that we're doing to the planet. I consider myself on a crusade for really sustainability and ensuring welfare for future generations, and I do see this as the most important thing that we need to do in the world right now. It's just incredible that we have this opportunity to make a change in an industry that has been growing for 12,000 years, and we're at that cusp of being able to really make alternatives that scale. So I just think this is the greatest thing, and that's why I came from medical world and medical entrepreneurship to this space. We didn't mention it, but I actually have started a company before that we sold to Boston Scientific, and it was a medical device that's now used in the clinic. And that has its own satisfaction that you're helping people. But the fact that you think that you're actually doing something that allows humanity to exist for much longer into the future, I think that's just a whole different ballpark. So I just want to kind of end with that, and I just want to say that it's amazing to be part of this community, and I'm super excited every time I hear new innovations and I hear new people come into this and try to help us make a change.
I love it. Thank you so much, Ali. I'd like to just say thanks so much for being a guest on the Future Food Show.
Awesome. Thank you very much, Alex. As always, I'm a big fan, and just an incredible opportunity to be here. Thank you.
This is your host, Alex, and we look forward to seeing you on our next episode.